This is the Robert Judat podcast, where emotional intelligence meets personal evolution. Stay curious.
Two particles, one in a lab in Geneva, one over 1,000 kilometers away, share a single quantum state. The moment a scientist measures one, the other responds. Instantly. No signal, no wire, no explanation that fits our everyday understanding of the world. Einstein called it spooky. 3 physicists won the Nobel Prize for proving it's real. And now, people are using it to explain why they can't stop thinking about someone they haven't spoken to in years. Today, we're getting into quantum entanglement, the actual science behind it, the metaphors it's inspired, and what it might genuinely mean for how we understand human connection. By the end of this episode, you'll know what entanglement really is, why the relationship metaphor is both compelling and complicated, and where the line between physics and poetry actually sits.
So let's start with the actual physics, because I think a lot of people hear quantum entanglement and immediately picture something mystical. But the science is genuinely wild enough on its own.
Right, like before we get to the love and relationships angle, we need to actually understand what we're talking about. So break it down for me. What is quantum entanglement?
Okay, so at its core, quantum entanglement is a phenomenon where 2 or more particles become linked in such a way that measuring one instantly reveals information about the other, no matter how far apart they are. And I mean that literally. According to Science Insights, this connection has been confirmed across distances greater than 1,200 kilometers.
Over 1,200 kilometers. That's not a lab bench, that's the distance between cities.
Exactly. And it's not just a theoretical curiosity anymore. This work earned 3 physicists the 2022 Nobel Prize in Physics. So when people treat entanglement like fringe science, they're about a Nobel Prize behind.
Okay, so how does it actually work? Like, what's happening at the particle level?
So particles like electrons and photons have a property called spin. It can be up or down. Before you measure an entangled particle, it exists in both states simultaneously. That's called superposition. It hasn't decided yet. But the moment you measure one particle and find it spinning up, its entangled partner, wherever it is, will always be spinning down, or both up, depending on how the entanglement was created. But the correlation is always there.
So they're like finishing each other's sentences, but at the subatomic level.
That's actually a pretty good way to put it. Caltech has this beautiful metaphor. They compare it to 2 dancers. If you observe one dancer and find them in a pirouette, you automatically know the other dancer must also be performing a pirouette. The connection is that tight.
I love that. But here's the thing that always trips me up. Doesn't this mean information is traveling faster than light? Because Einstein said nothing can do that.
This is the part that even Einstein couldn't fully accept. And the answer is no information actually travels between the particles. Science Insights puts it really well. There can be correlation without communication. They use this analogy of tearing a photograph in half and sealing each piece in an envelope. Opening one instantly tells you what's in the other, but nothing traveled between them.
Okay, but the particles are weirder than the photograph, right? Because the photograph always had its half. The particles don't have a defined state until you measure them.
Exactly, and that's the part that drove Einstein absolutely crazy. In 1935, he and colleagues Boris Podolsky and Nathan Rosen published what's called the EPR paradox, arguing that quantum mechanics must be incomplete. His logic was, if you can predict the state of a distant particle by measuring its partner, that state must have been real all along. But quantum mechanics says it doesn't exist until it's measured. Einstein called the alternative, that 2 distant objects are somehow not independent, spooky action at a distance.
And he was wrong.
He was wrong. Experimental confirmation came in the 1970s through work by physicists John Clauser and Alain Aspect, whose studies showed that quantum mechanics, not classical physics, correctly described what was happening. The spookiness is real.
So we have this phenomenon that even Einstein thought was too weird to be true, confirmed by Nobel Prize-winning experiments operating across over 1,000 kilometers. And NIST physicist Andrew Wilson described entangled particles as having, and I love this quote, no independent existence. They behave as one object.
Right. And once you sit with that phrase, no independent existence, you start to see why people immediately reach for relationship metaphors. Because that's exactly what deep human connection can feel like.
Okay, so let's make that turn, because this is where it gets really interesting to me. How did quantum entanglement go from a physics lab to being used to describe love and human connection?
It's been a gradual thing. According to a detailed exploration by Timothy Kilimo on Snowcap, researchers and thought leaders have been exploring whether quantum entanglement can offer insights into human relationships, specifically things like empathy, intuition, and what they call synchronous experiences. The idea being that when two people are deeply connected, the state of one affects the state of the other, regardless of distance.
Which sounds like every long-distance relationship ever.
Ha, right? And Kilimo is careful to note that applying quantum mechanics to human consciousness remains speculative. But he argues that exploring this intersection invites fascinating dialogue and potential future research. It's not a settled science, it's a productive metaphor that's generating real questions.
And pop culture has been way ahead of the scientists on this one. Like the red string of fate, that ancient myth about two people connected by an invisible thread, has been showing up everywhere.
Yeah, and according to Indigo Music's piece on the red string theory, that myth has found a home in some of the biggest stories in recent years. The anime Your Name, Kimi no Na wa, is basically the red string of fate as a quantum entanglement story. Two characters, Taki and Mitsuha, connected across time and space, their bond symbolized by a literal red ribbon.
And K-dramas like Crash Landing on You do the same thing. Love as something written in the stars, crossing borders and obstacles. Western films like The Lake House and Serendipity too.
Exactly. And what's interesting is that the word entangled itself has permeated everyday language. Warren Boutin's piece on Skifi Dimensions points out that the term has moved from physics labs into literature, film, and everyday conversations. It's become shorthand for a kind of profound interconnectedness that transcends physical distance.
And there's a whole field, quantum psychology, that's trying to formalize this. Which, okay, I have to say, the origin story of that field is kind of wild.
Oh, tell me.
So according to Psychology Fanatic, the term quantum psychology was first coined not by a scientist, but by science fiction writer Robert Anton Wilson in his 1990 book Quantum Psychology: How Brain Software Programs You and Your World. A sci-fi author got there before the academics.
Which honestly tracks. Writers have always been better at sitting with ambiguity than scientists are. And the field, such as it is, proposes that consciousness isn't solely confined to the brain, that it extends beyond it and can influence our experiences and reality.
Okay, but I want to push back a little here because I think there's a real risk of the metaphor running away from the science. Like, quantum entanglement operates at the subatomic level. We're made of atoms, sure, but does that mean our relationships are literally quantum entangled?
That's the right question to ask. And the honest answer is, probably not in a literal sense. The Caltech Science Exchange is clear that entanglement reveals itself at very tiny subatomic scales. The leap from particles to people is enormous. But here's what I find genuinely interesting. The metaphor isn't just poetic fluff. It's generating real academic work.
Like what?
So, in 2024, a graduate student named Akasha McMillan Heinzig at Pacifica Graduate Institute submitted a thesis, Quantum Psychotherapy, exploring the interplay between quantum physics and analytical psychology in therapeutic practice. It's a serious academic work, 69 pages, exploring how quantum principles like uncertainty and entanglement could inform new therapeutic strategies and frameworks.
So someone is literally writing a master's thesis on this.
Right. And Heinzig's key argument is that models of reality shaped by beliefs and perceptions significantly impact how psychotherapy works. The thesis identifies a gap in research linking quantum physics and psychotherapy and tries to bridge it. It's speculative, but it's rigorous speculation.
And therapist Mel Schwartz has been doing something similar in practice. He's been using quantum physics as a lens for marriage counseling, mapping concepts like wave collapse and entanglement onto the experience of falling in love.
Yeah. And his argument is that by mapping quantum concepts onto romantic relationships, you can find new ways to sustain love and maintain authentic communication. It's not about the math, it's about the framework. The quantum world gives you a different set of tools for thinking about connection.
Okay, so we've got the beautiful side of this metaphor, but I want to go somewhere darker because I think this is where the entanglement idea gets really honest about what human connection actually is.
Go for it.
There's a paper published on Medium in May 2026, written by Jennifer Santiago and a co-author, that uses quantum entanglement as a metaphor for traumatic bonding. And it's based on a real case. Jenny Santiago wrote a memoir called The Tangled Obsession about a prolonged stalking situation she experienced.
I've read that. It's genuinely unsettling in the best academic way.
So the paper maps the stalking situation onto quantum mechanics. The initial intense contacts are described as establishing the entanglement analogous to two particles interacting. And then, despite multiple attempts at physical and legal separation, changing locks, involving law enforcement, temporary relocation, the correlation between the two parties persisted.
Which mirrors quantum non-locality. Physical distance failed to decouple the states. And, the paper goes further, every external intervention, every police report, every time Jenny wrote publicly about the events or pursued a new relationship, it functioned like a measurement in quantum terms. It forced a correlated outcome from the other party.
That's a really dark reframe of the measurement and collapse idea.
It is. And I think it's important because it shows that the entanglement metaphor isn't just romantic. It can describe enmeshment, trauma bonds, relationships, where the correlation between two people becomes something that resists separation, even when separation is desperately needed.
So the same metaphor that describes soulmates also describes something much more painful.
Exactly. And I think that's actually the most honest thing the metaphor offers us. Because in physics, entanglement isn't inherently good or bad, it's just a state of correlation. Two particles that have interacted become entangled such that their joint state cannot be factored into independent states. That's neutral. What matters is what you do with it.
And in relationships, the same is true. The connection itself isn't the whole story, it's whether that connection is generative or destructive.
Right. And this is where I think the metaphor actually earns its keep, because it gives us language for something we've always known intuitively, that some connections change you at a level that doesn't fully reverse. NASA's piece on quantum entanglement says that once entangled particles separate and move far apart, they shed their original quantum states and take on a new, united quantum state, which they maintain forever.
Forever. That's a big word.
It is. And I think most people, if they're honest, can point to at least one relationship that changed them in a way that felt permanent. Not because the other person is still in their life, but because the interaction itself rewrote something.
And the emotional contagion piece fits here too. The Skiff-I Dimensions piece talks about how our emotions are mirrored and amplified by those around us. Witnessing someone's joy sparks joy in us. Being around someone in grief pulls us towards sadness. That's described as a subtle form of entanglement.
And shared experiences deepen it. The piece talks about how shared experiences forge bonds and create a common narrative, whether it's overcoming a challenge together or just sharing a laugh. These moments create a shared history that ties people together. That's the human version of two particles interacting and becoming correlated.
Okay, I want to go back to something you said earlier, that the metaphor is generating real questions. Because I think there's a version of this conversation where we just say, it's a nice metaphor, don't take it literally, and move on. But it feels like there's more at stake here.
There is. Because the metaphor shapes how we think about relationships, and how we think about relationships shapes how we behave in them. If you think of connection as something that can be fully severed, like classical physics, where an apple on a table stays there until something moves it, you approach relationships differently than if you think of connection as something that leaves a permanent mark.
The classical physics view of relationships versus the quantum view.
Exactly. And Mel Schwartz makes this point in his work. He calls it mechanistic thinking about relationships, where we treat people like predictable objects that follow fixed rules. The quantum perspective disrupts that. It says, the act of observing changes what you're observing. The act of being in a relationship changes who you are.
Which is both liberating and a little terrifying.
Very much both. And I think the research from Akasha Heinzig's thesis captures this well. She argues that models of reality, shaped by beliefs and perceptions, significantly impact psychotherapy processes and outcomes. In other words, the story you tell yourself about how connection works actually changes how connection works for you.
So the metaphor isn't just descriptive, it's prescriptive. It changes behavior.
That's the argument. And it's why I think this conversation matters beyond just being a fun physics meets feelings topic. The framework you use to understand your relationships has real consequences.
Let me ask you something that I think a lot of listeners might be wondering. Is there any risk that using quantum language for relationships actually does harm? Like, does it give people a pseudo-scientific excuse to stay in bad situations? We're entangled, I can't leave.
That's a really fair concern. And I think the Jenny Santiago case is actually the best answer to it. The paper uses the quantum metaphor precisely to name what's happening in a traumatic bond, not to justify it, but to understand it. Naming the pattern is the first step to disrupting it. The metaphor can be a diagnostic tool, not just a romantic one.
So it's about using the framework responsibly.
Right. And the physics itself is actually instructive here. In quantum mechanics, entanglement doesn't mean the particles are trapped. It means they're correlated. Understanding the correlation is what allows scientists to work with it. In quantum computing, in quantum cryptography, the knowledge is the tool.
I love that. Understanding the entanglement is what gives you agency over it.
Exactly. And I think that's the most actionable thing anyone can take from this conversation. Whether you're in a relationship that feels like the good kind of entanglement, where knowing the state of one person tells you something beautiful about the other, or the kind that resists separation even when it should, naming it clearly is where the work starts.
So when you step back from everything we've covered today, the Nobel Prize winning physics, the pop culture myths, the therapy frameworks, Jenny Santiago's story, here's what I keep coming back to.
What's that?
The science of quantum entanglement is real, confirmed, and genuinely strange. Particles that have interacted share a state that cannot be factored back into independent parts. And whether or not that literally applies to human beings, the metaphor it offers is one of the most honest descriptions of deep connection I've ever encountered.
And it works in both directions. The Caltech description of entanglement as an emergent property, something that arises from the connection between particles, like a ballet or tango emerging from individual dancers, that's not just physics. That's what it feels like to be in a relationship that's working. You become something neither of you could be alone.
And the NASA framing, that once entangled, particles shed their original quantum states and take on a new, united quantum state which they maintain forever, that's also what it feels like when a relationship ends but still leaves a mark. You don't go back to who you were before.
Which is either comforting or confronting, depending on the relationship. But it's honest. And I think that's what makes this metaphor worth taking seriously, not because it's literally true at the human scale, but because it captures something true about the human experience that our usual language doesn't quite reach.
Here's what this really comes down to. Quantum entanglement tells us that the universe, at its most fundamental level, is not made of isolated, independent things. It's made of correlations, relationships, states that only make sense in reference to each other.
And maybe that's the deepest thing the physics is telling us, not just about particles, but about what it means to exist at all. You are, in part, defined by what you've been entangled with.
Einstein called it spooky. But maybe it's just love, doing what love has always done, connecting things that have no business being connected, across distances that should make it impossible, in ways that don't fully reverse. Thanks for listening to Co-Pilot Podcasts. The next time someone says you two are inseparable, now you know that's not just a metaphor. It might be the most accurate thing physics has ever said.